Oh, good morning. I must admit I've completely lost the time zones as to what I'm in at the moment.
It's afternoon in New Zealand.
Well, true. Okay, so anyway, this is SharePoint Business Continuity Management, which basically means how do you do backup, how do you do disaster recovery, and how you do high availability using SharePoint. Basically, if we flick through this next slide, my name's Ewington. Based on my accent, yes, I am from New Zealand, so hopefully the rest of you can actually understand me. I've had a bit of a checkered history with regards to my career. Basically, prior to joining Microsoft, I was an IBM CIX COBOL DB2 mainframe developer, which was actually quite bizarre. When I first joined Microsoft, I'd actually never put any PC-based application into production. Also, prior to joining Microsoft, I spent 6 years in IT management, doing the delusionment of going through being a development manager, IT manager, being project manager, etc., and doing some weird and wonderful stuff. I then joined Microsoft back in 2000, and I've actually had a bit of an interesting career with these guys as well. Although I've been working for Microsoft since 2000, I've actually left about 5 years ago for about 6 months, and as my colleagues like to remind me, Microsoft made the mistake twice of hiring me. Basically, I'm a principal consultant based in Auckland, New Zealand, and I've been working with SharePoint for quite a while, going right back to 2001, those Tahos and Encompass Resolution days. Basically, I decided to have a bit of a love-hate relationship with SharePoint, decided to apply myself and decided to go through the certification process. So I got the Microsoft Certified Master of SharePoint 2010, then went through and did the Microsoft Certified Architect certification and got grandfathered into the Microsoft Certified Solution Master certification, did the upgrade rotation with a number of people back in January, and basically kind of suffering for my sins as a consequence. Also, as part of working for Microsoft Consulting Services, I'm also part of the SharePoint Ranger team. So basically, this is work that we actually do as part of the SharePoint product team, where they get us to go out and work on key critical deployments that are out there. And for my other sins, as part of doing that, I'm also part of the SharePoint MCSM SharePoint instructor team as well. So although you may not necessarily see me as part of doing a rotation, you'll definitely know that I've had an influence on there, which we shall remain nameless. My email address is up there, so if you've got any questions or anything follow up, don't hesitate to contact me from that.
Okay, thanks, Wayne. So, great introduction from Wayne. My name is Neil Hodgkinson. For those of you that were in my session yesterday, you've heard all this before. Prior to joining Microsoft, I was a SharePoint specialist working for CSC for about 5 or 6 years. And prior to that, I was a process chemist working in the field of drugs, poisons, and explosives. So no upsetting questions today, please. At Microsoft, I've been here since 2005. I'm a service engineer, or senior service engineer in 365 operations, part of the SharePoint product team, which is a pretty interesting place to work, I must admit, especially as we're going through the whole Office 365 revolution at the moment. Like Wayne, I have 2 of the 3 certifications that Wayne has, the Solution Master and the Certified Master. I don't have the Architect. I'm not that good. And I'm also an instructor on the MCSM team. I teach Search, BCM, and SQL Server. And my contact details are there. I know there's plenty of tweet feeds going around, so you can get hold of me if you need to. Picture, all coming to the party tonight? Yeah, you all went to the party last year? That's me and Wayne at the party last year. It's a great night. If you've not been before, you'll really enjoy it. Anyway, so the agenda, what we're going to cover today. We're going to talk about HA and disaster recovery. We're going to cover things like definitions. What's the terminology mean? What are we talking about when we refer to things like warm standby, hot standby, high availability, disaster recovery? We're going to cover a technology overview. So what features do we have? What functions and features do we have primarily in SQL Server to allow us to perform or provide the level of service availability that the customer is looking for, that we're looking for ourselves? We're going to cover not only SharePoint, but we're going to touch briefly on the fact that now, obviously, as you know, Office Web App Server and Workflow Manager are now separate from the product. So we need to think about high availability and disaster recovery for those pieces of technology as well. And then we're going to get into 2 scenarios where Wayne's going to go through a fairly comprehensive demo on building out a SharePoint highly available solution and building out a warm standby solution. I'll let Wayne talk more on those when we get to it. So definitions. First thing we're going to talk about, as I said already, is definitions. So we're going to cover these 3 points. Concept of high availability and what does it actually mean? What does it mean to many people? It has a different meaning for many people. The concept of disaster recovery. And then we're going to get into this somewhat hot debated topic of stretch farms. So we're expecting questions on that one. So what is high availability? I won't read this out per se, but or carte blanche. There's a Wikipedia definition of what we mean by high availability. Fundamentally, what we're saying is providing a solution that offers a level of capability such that there's a minimum disruption or minimum interruption to business in the event of one or more services within that application failing. Really about protecting or defining and protecting what we refer to as our service level agreements. So any of you out there that are working on production systems or even pre-production systems will have service level agreements with your customer. In Office 365, in the place where I work, we're fairly comprehensive on our service level agreements, specifically with the dedicated space. We have some very tight restrictions on what we can and can't do and what we can offer for outage years and maintenance windows and things. We'll talk about those in a few minutes. And then there's the concept of the agreed fault domains. So here what we're talking about really is which component of the service is available to fail. So in the scenario of Office 365 dedicated, for example, we have an SLA that says we must maintain availability of the service and people and customers being able to access their content to within a certain criteria. But if search fails, we don't care. Well, not that we don't care, but we don't have an SLA against it, so we're not measured against that metric. In terms of service level agreements then, the classic scenario, it's a definition of what are you agreeing between all the components of the service. So in order to provide a service level agreement, in this case, 3 nines is the classic statement. So we want to offer 3 nines availability, which basically saying we can have 43-ish minutes per month of unplanned downtime. And there's an important distinction. It's almost impossible to achieve any of these metrics if you're going to factor in the concept of maintenance windows. So you can't include, you could, but you shouldn't, or maybe wouldn't include maintenance windows in these numbers, because I mean, how could you possibly even deploy a full trust solution if you're trying to achieve this level of high availability? It's not physically possible. So you really need to factor in all of the capabilities of not only the service that you have from a SharePoint perspective. Think about your Active Directory, think about your SQL Server components, think about your DNS, think about your network. You can't offer an SLA that is shorter than the slowest recovery point or the slowest of those services to recover. Okay, and typically, as I said already, 365 and dedicated, 3 nines is our target. We're pretty good. 95% of the time we hit 3 nines availability. Most of the time we're actually above that in planned SLA achievement. So the question is, what are we protecting against? So from a point of SharePoint high availability, we need to think about all the pieces in the puzzle, if you like. Think about the simple things like, what about the data center? We need to prepare for that. Data centers, typically, how do you provide high availability for a data center? Well, the only option you have is to build another one. That's an expensive thing to do. Just typically, you'd build something in a different geographic location. Might be a shared co-hosted data center, or you might indeed build your own. The Microsoft scenario is, in the US alone, we have data centers on both coasts. We have data centers down the middle in the central region as well. And we do replication and things around there. So we build data center redundancy by having multiple data centers. Then we can think about the rack. And we're going to talk a little bit more about some of these individual features. We'll think about from the data center down to the rack. The rack is hosting your servers, whether they be physical servers. Thinking about the rack's power supply, the network capabilities, what redundancy we're going to build in there. All these points of failure are what we call fault domains. And we need to make sure that if our SLA is saying, for example, we need to protect against power failure or power supply failure, we need to make sure we have sufficient redundancy to cover that scenario. And if we don't, then we're not providing redundancy at that fault domain level. So a key thing about building a service then is the concept of, what components do you need inside the data center, inside the racks inside that data center to be able to support or maintain your SLAs. So think about this concept of what we call the Franken rack, or the kind of custom-built, hideous solution that will get you what you need. And if we think about the very simple point, here's our rack. Well, what do we put inside the rack? Generally, inside any rack, you have a power, that's supposed to represent a power powertrain. Then we have our network, so a simple switch. And then we have our servers and disk arrays and whatever they may be. But does this provide us with any level of high availability? Well, the answer is obviously no. We've got one power supply. We've got one network switch. It should light up, there we go. No, we've got no redundancy at all at that level in this particular rack. So if this rack was to suffer a power outage, if the feed to this rack was to go down, you've lost every single service in that rack. So this is what we call the level of a fault domain. So what do we build? Well, we add more. We add another powertrain, we add another network switch. Maybe we add even more because we're really, really paranoid about the possibility of losing capability. And then you get to the point where the people in your data center start to hate you because your rack's non-standard build. It's built to support something you want to provide. It isn't built to support necessarily the services that they want to provide in terms of repeatable deployments. So, thinking about the fault domains then, how would we build it instead? We'd provide 2 racks. So instead of building one rack with loads of bits and pieces in it to try and support that scenario, we build 2. So we've now moved our fault domain out to be the rack level. We can support failure now at the rack level. If this side goes down, we're fine because we've got another one. Built the same, has redundancy. But what about what's inside there? We need to think about things like, what about the individual machines? What are the machines doing? What services are those machines hosting? So it's no good having a SharePoint farm with all of your databases on this side and all of your application servers on that side, because if you lose either, you're out of luck. So we need to think about the services. We have different machines, different services. On the left-hand side rack here, we're hosting a whole bunch of SharePoint service applications or SharePoint services. On the right-hand side, we have another set of services. Are we still highly available? There's no prize, but can anyone answer the question? No. What's the problem? No secure store. So if we have an SLA that requires us to have a secure store available at all times, we're still no longer in a position where we're actually providing high availability. So we need to think about that, and we'd add a secure store in there. Basically, make sure you're replicating all your data. In some deployments that I've seen, you find scenarios where you have many racks, and then people will literally stripe services across them all. Almost in kind of your RAID scenario for a disk data array, you stripe services such that you've got multiple services with a redundant, almost like a redundant service built in as well. So that's kind of covers roughly the kind of high availability thing. So what about disaster recovery? And here we're really concerned with how do we build a solution that is we can bring back online, ideally in the shortest amount of time possible, such that we can continue our business. And when we think about disaster recovery, that's the key thing. It's continuing the business. It doesn't necessarily mean that the platform, your primary environment, is super performant platform, and your disaster recovery scenario, or your disaster environment has to be performant at the same level. It's all about business continuity, and that's the key thing. I'm not going to say you don't need to spend an awful lot of money on DR. You should spend as much as you need to build a DR scenario, or build a DR solution. But fundamentally, it doesn't have to be, if you've got 12 servers in your primary site, you don't necessarily need 12 in the disaster recovery site. You need to be able to continue the business service. And when we think about DR, we have to think about these requirements. So the two key requirements that people talk about is the concept of recovery point objective and recovery time objective. And those two things are important. From a recovery point objective, we're really looking at what point in time do I need to recover my solution to? And from a recovery time objective, it's at how long is it going to take me to reach that point? So the example there is, I can lose 60 minutes of data, and all of my data can be inaccessible for 3 hours. That could be an SLA, requirement that you have. In Office 365 Dedicated, our RPO is 15 minutes and our RTO is 4 hours, which is reasonable. It's not bad. We can achieve it fairly easily. But depending on the nature of the business, if it's a critical financial application, even online casinos, for example, their RTO and RPO is way less than this, because they lose a serious amount of money if they go down. So thinking about purely from a database transactional perspective, those guys need seriously short times. And because they make an awful lot of money, they'll invest a lot of money. And that's where we come to the concept of the RPO and RTO versus cost. So a colleague of ours former colleague of ours, has a pretty interesting analogy here where he says, if you want to try and achieve kind of the minimum RPO and RTO, you want to get to this point where you've got an enormous level of availability, and you can recover from a failed primary site to a DR site in 5 seconds. You're going to basically classify it as trying to boil the ocean. It's literally impossible. And to do it, if you wanted to do it, the cost will be astronomical. So you've got to consider this as a tipping point. It's a seesaw, in effect.
It's also quite funny too, just an analogy around this, is that usually what happens is that you talk to the business users and they go, well, how much data do you want to lose? And they go, 0. How quickly do you want to have it back? And they go, within a couple of minutes or within 0 minutes. Okay, so you do your design around that, you then give it to the chief financial officer and he goes, hell no, because of the costs that are actually associated with this. So it's quite an interesting discussion that often happens.
Yeah, it's very much, it's a compromise situation, really, in terms of how much money you've got versus what your timeline's at, as Wayne said.
So, how many people here have done stretch farm topologies? Okay, right, very interesting. So just for those that haven't done stretch farms or haven't come across them, basically the whole premise behind these is that you could actually have servers that were in the same physical farm being located in 2 different data centers. So this kind of looked, it kind of looked okay-ish. There was a Technic article back out there for 2010 that had a bit of a reference around this concept of actually doing a stretch farm. So basically the idea behind here is that you could potentially have your servers located in 2 different data centers as long as there was a network latency of less than 1 millisecond between those 2 locations. Now that kind of worked, and people went, this is a great thing that we actually tried to do here. And people kind of started talking about it and started using it. Now if you kind of digest it back a bit, the reason that a lot of people went for this topology was that, why do I need to stand up another farm elsewhere and have these servers actually not being utilized and doing anything? So people went, right, we're going to actually use these servers and make the most of them. So that kind of went, yeah, that's okay. So what they essentially did as part of the stretch farm topology was that you came up with what we call a high availability type solution. Now I'm being very clear about this. This is a high availability solution or topology. It is not a disaster recovery one. It's about high availability. Now the other interesting thing about this though was that although we kind of had this 1 millisecond network latency requirement in here, not everyone actually obeyed or actually adhered to it. So as a consequence, what actually happened was that not everyone actually met this requirement, and because SharePoint's so dependent on SQL, there could actually end up being some mild corruptions in the databases, which came out and was associated with that. So as a consequence, for when 2013 came out, there was a blanket statement that came out and said that stretch farms are no longer supported. And the definition around this was actually saying that it was based on a physical data center. So this actually makes it quite interesting. What actually constitutes a physical data center? Well, a physical building. So if you've got 2 buildings which are side by side, okay, and you've got servers located in the 2 different buildings, by definition you've got a stretch farm topology, which was not supported. But then if you kind of think about it's like the Boeing factory. Imagine if you had your data center being the Boeing factory, which is a huge, huge building. That's one physical building. You may or may not be meeting the network latency requirements, but conversely, you're still a physical building, so you didn't have a stretch farm. So there was a bit of a backlash as a consequence of this, because a lot of people said, well, I've actually got my data center next door. I want to be able to support this, so what are you going to do about it? So as of April, in fact, a couple of weeks ago, about last week I should actually say, the support statement actually changed to be logical data center. Now there's a very crisp and very precise definition around this, which is basically as per what we've got from the Technic article put out there. It basically means that you've got to have a network latency of less than 1 millisecond, 99.9% of the time over a period of 10 minutes, and that you need at least 1 gigabyte per second bandwidth per speed between them. Okay, so this is another approach you could potentially do. However, don't get me wrong, I'm not actually advocating that you do stretch farms. I'm just saying be careful if you do them. They may not always resolve what you think you're resolving. And if you do them, there's a couple of extra things that you should actually do. Basically, if you're going to do this, what you should also be doing is actually monitoring your SQL latency associated with this as well. So what we've got within SharePoint is that we have actually got the logging database. So by default, this isn't actually been enabled, so you need to go in via PowerShell. You need to go in and enable the SQL latency usage, so it's actually going to put that information into the logging DBs for you. What you can then do is actually start running queries against that to make sure you're actually adhering to that recommended standard or recommended guidelines that we've got. If you're not, you're in an unsupported state. If you are, you may be okay, bearing in mind that you could still get up with mild database corruptions, etc.
Yeah, and the optimum word being may be okay.
You may be okay. Okay. Now the reason for bringing this up is that there is a couple of scenarios where you can get into doing, as part of your HA and DR designs, using some of the technologies that we've got, which could potentially put you back into a stretch farm topology. So this is the reason for bringing this up now.
Thanks, Wayne. So let's think about the actual technologies that we're going to use to build these capabilities. Most people will have done this type of design. You've all seen the back of the fag packet design, the little, the napkin in the restaurant. Don't go and give that to an architect. Well, an architect probably drew it, actually. Wayne?
Well, actually, how that design actually came across, Neil and I were doing a link meeting, trying to work out what we're going to actually cover in this talk, and this is what we actually drew up in OneNote.
Yeah. So this is the sum of the talk can be summarized in that diagram. So we're going to look at some of the technologies that we have. The failover clustering, that's been around for a long time. Database mirroring, log shipping, and always-on availability groups. Always-on availability groups is this cool new feature. Is anyone actually doing that now? For real? 2. Couple. Very good. 4, 3. Okay, so let's look at what we have. Failover clustering. Failover clustering. Been around for a long time, as everyone's seen the kind of SQL Server. I've worked on environments where the DBAs have been very loath to do anything except SQL Server clustering. It's what they're used to, it's what they like, it's what they're happy with. Key thing that's interesting or the key risk with using failover clustering is the fact that we have this single shared volume, or shared disk volume. So we're running a risk that if we lose our disk, we've basically taken down the whole cluster. So it's always a risk that we have with failover clustering. But from a failover perspective, from a high availability solution perspective, very good, very common technology. And then we have concept of database mirroring. So there's 2 types of mirroring. The first one we're going to talk about is synchronous. So synchronous gives us our high availability configuration. And basically the way we do this, we mirror the data as part of a transaction. So if we look at our SharePoint servers and 2 SQL servers, our request goes into SQL. The request is transmitted across to the secondary SQL server as well. So, it's transmitted across to the secondary SQL server. That transaction needs to be hardened into the log or written to the log file on the secondary SQL server before it's written or before the primary SQL server will commit it. So we're basically establishing a scenario where we know we've got a defined written backup copy of that transaction on a separate SQL server before we acknowledge that back to the client and say, yeah, we're good. So we know at this point in time, we've got synchronous replication, we've got identical copies of the data on both sides. Another advantage of the database mirroring perspective is that it gives us this thing called auto page repair, which basically means if the system detects, or if the SQL server on the left-hand side here detects that there's a problem with a page in the database on the left-hand side, it will go and seek out its identical copy, or ideally its uncorrupted copy on the secondary, and then rewrite that data back to the primary. So there's kind of an auto recovery and capability in there as well. One thing to think about with this one, coming back to the comment about network latency, between the 2 SQL servers for synchronous replication, we're talking about local data center, local same rack or certainly same data center. You don't want any network latency in there. If you introduce network latency between the 2 SQL servers, you run into a scenario where the SQL Server transactions can't keep up, and you'll find that your SharePoint site goes down because you can't keep up. And this happened to us live in Office 365 Dedicated just last week, where we took down an entire database of content purely because mirroring couldn't keep up. Just because somebody went in and selected about 120 gigs worth of data in a single document library and deleted it. That was purely because we had a slight network issue at the same time, so just be wary of that one. From an asynchronous perspective, now we're talking about a scenario where we're really looking at not necessarily high availability, in fact not high availability at all. It's more suitable for DR type scenarios. And in this case, we're basically saying we're going to replicate our data across, or we're going to mirror our data across to that other server. We want to make sure it's got there, but we're not going to be too concerned, or we're not going to care about was it truly committed to that disk before we actually write the transaction back to the SharePoint server. So at this point, we don't know that we're actually going to succeed that transaction across on the mirror. but we're already acknowledging to SharePoint that we've accepted it. So from a HA perspective, it isn't really giving you HA because you can't guarantee that that data is always going to be completely in sync. So you can't say, if I suffered an outage in this situation, how do I know I've committed all my transactions? So there's a potential for data loss. So you wouldn't necessarily use this in a HA situation, but you would use it mainly for DR. In summary, for mirroring, it is a very cost-effective solution. Unlike SQL clustering, where we don't have this reliance on specific type of hardware and our clustering hardware being the same on both sides, or however many nodes we have, all of the server hardware has to be the same, all of the patching levels have to be the same. We don't have that restriction. So we can use, basically you can use highly performant servers on your primary site, you could use less performant servers on your secondary location. It doesn't really matter, we're not concerned about that. It's incredibly straightforward to set up. If any of you have done it, setting up mirroring, it's very, very easy. It's even easier with SQL Server 2012 because you can drive the whole thing through wizards and it works extremely well. Key things is it's the fact that it works at the database level. So unlike SQL clustering, where we're talking about an instance level failover and all of your DBs go over at once, we now can work at the database level. And that gives us one key thing. It means we can also use the compute power of both sides of the mirror. So if we're in a HA situation where both our SQL servers are local, we can have active databases on both nodes with mirroring replicating across. So we're not wasting CPU power. You may or may not see a hiccup while it fails over, depending on how big the database is, how many transactions are going through. You may or may not, and if the database is synchronized in a synchronous scenario, that hiccup will be incredibly small and maybe even not noticed by your end users. And the beauty of it is that a lot of applications these days, not only SharePoint, but many other applications are also mirror aware. So we can support this concept of the failover partner. And when the mirror auto fails over, assuming you have a witness in there as well, the application can just carry on and will read from the secondary location. The third one, log shipping. This has been around for a long time as well. Effectively, in this scenario, what we're doing is we're literally just backing up the transaction logs at a predefined period of time and sending across those transactions to another set of SQL servers, either one or more SQL servers, just to basically provide. Typically, we use in a DR. It's not quick enough for high availability. There's always a potential of data loss in this scenario because you wouldn't roll your transaction logs across quick enough. But for a good disaster recovery strategy, this is probably one of the most common features you'll ever find, if not the most common. And the beauty of it is you can ship to multiple secondaries. So you could ship to a local secondary, and you could ship to another secondary that's maybe geolocated somewhere else. It's fully supported to do that. Putting it all together, including clustering, mirroring, and log shipping. So what we're seeing here basically is kind of a scenario where what could we do? Well, there's all kinds of options in this scenario, in this capabilities. We can have local clustering. We can then mirror those clusters. We could mirror that cluster to another cluster. We could then log ship that cluster as well. So there's all kinds of things we could do. You know, the complexity really comes into how much money have you got to spend? What are your SLA levels? You know, what are you trying to protect, and how much do you need to protect it? In 365 Dedicated, and I keep using that analogy, but we do local mirroring, and then we do log shipping to a remote data center. We do mirroring of that data center, and at every step of the line, we're also taking full backups. So we're kind of, at any one point in time, we have 6 copies of any customer's data in flight. So we know we can always recover. We can't afford not to. It costs a lot of money if we can. So any combination of these these processes, depending on what your RPO and RTO are, depending on what your, what financial restrictions you might have in terms of what you can implement, I wouldn't say that the possibilities are endless, but they're certainly very flexible. And then we come to the concept of always-on availability groups. Now, I'm going to give you kind of a very brief one-slider overview, and then Wayne's going to really demo this stuff. So it's a new functionality. It's almost like a hybrid between a cluster and a mirror, in that the clustering side of things is purely at the Windows level. So we build a Windows server cluster, but we don't then have to install SQL Server in a cluster configuration, which is where the complexity kind of comes into the clustering side. It supports a number of, it supports 2 different commit levels. We have the concept of sync commit, which is very similar to your synchronous mirroring in SQL Server. And we have the concept of async commit. And again, unlike the mirroring technology that we have in SQL Server 2008, for example, we can do sync commit to up to 3 replicas. So we can have multiple copies of our data in different locations. And from an async commit, we can have one async commit replica but that replica doesn't have to be local. We can use that as a DR strategy for a standby solution, which is what Wayne's going to demo. So thinking about what we're going to use, what would we use and when would we use it? Depending on as I said already, options, I need to stand over here. So it depends. We talked about basically about RPO and RTO and getting them as small as possible. Well, these are the technologies that can give you that shortest possible RPO and RTO. So from an always-on sync, mirroring sync, and failover clustering, they're synchronous technologies. In the concept of failover clustering, they're synchronous and it writes to the same database on a shared disk subsystem. But there's a risk, and the reason we've kind of blown that out is from an RTO perspective, failing over from a SQL clustering, if your SQL node fails, that's great. You fail over and everything's great. What if you lose the shared disk? Okay, then you're into a backup strategy scenario. So it's potential that failover clustering can, while both nodes, while one node in the shared disk is operational, you're in good shape. If you lose the disk, you're going to run into a scenario where you could be into backup strategy. Depending on what your backup capabilities are, you might be running into days, potentially even weeks to recover from that. And then the other options we have, so asynchronous mirroring and always-on async. Again, it's asynchronous, so there's a risk of potential data loss if you fail over these technologies. There's also a time-based. So if you failed over, for example, manually failed over an asynchronous mirror, you would have to wait for that mirror to synchronize before the data would become available on the other side. So there's a time lag for that to catch up. For log shipping, again, typically most people I talk to do like kind of 15-minute log shipping windows, so there's instantly a 15-minute catch-up point if you fail over a log ship database. And then, potentially, depending on how many logs there are to replay back on the secondary, you could be looking at a serious number of minutes, potentially hours, before that could be recovered. And if you're in a really bad situation, even days or weeks. And then finally, from a backup and restore perspective, if you were doing native SharePoint backup and restore, you've really got to think about, how long is that going to take me to recover? It will take a long time. You're really looking at, if you can do it in hours, you're very lucky. But typically, you'd be looking at recovering a farm in days or weeks from a SharePoint backup perspective. And the other applications that we talked about, so Office web apps, the key thing here is that we don't have any persistence in Office web apps. We don't really care where the farm is located. So from a high availability perspective, all we do in SharePoint is, all we're really concerned about in SharePoint is that our end users can reach both farms. They need to be able to render an iframe from the Office web app server that contains the document that you want to render. So we have a low-balanced SharePoint farm connected to a low-balanced Office web app farms. Inside the web apps farm, there's all kinds of options that we're not going to get into here in terms of how many servers you can have for different roles and that kind of thing to provide additional redundancy. But the key thing is from a HA perspective, if you low-balance SharePoint, you low-balance Office web apps, in theory, you're in good shape. From a DR perspective, if you lose the web apps farm, it's not difficult to recover. So basically all you would need is a standby Office web apps farm that's just sat there doing nothing. And then if you fail, if you lose your primary, all you have to do from a SharePoint perspective is remove the WAPI binding to that primary farm and then recreate the binding to the secondary. And as long as everything else is equal in terms of the permissions and the networking and the DNS, you should be great. You should have no problems at all. Workflow Manager is a whole different ballgame. So the concept of the one or the three servers. So I like to bring in the concept of Brother Maynard and the Holy Book of Armaments from Monty Python here, in that you can only have one or three servers. You cannot have 4, and 5 is right out, as they say. The reason being it's completely dependent on the service bus. So with one server, that's great. One server can decide itself whether it's up or down, or the system will know whether the server's up or down. With 3 servers, that's fine. The reason for 3 is because we can form a quorum. If one fails, the other 2 can decide that we're operational and we're going to carry on working. If you have 2 and one of them failed, how does the one that's still working know that it's the only one that's working? So should it continue to work or not? You get into this, have any of you heard of the concept of what we call split brain scenario? So the servers will not know which one's the primary, who should be controlling the workflow manager farm, etc. So, and then from a DR perspective...
just before we go on, there's actually a key point about this. This is actually supported guidelines. So the support guideline is either 1 server or 3 servers. So although you can do 2, 4, 6, 8, you would actually be in an unsupported situation. Okay, so a lot of people I know have actually gone out there and go, but it works with 2 servers or it works with 4 servers. Yeah, well, it kind of works, but your high availability is not actually going to exist and you're actually in an unsupported state. So it's either 1 or 3. As to why that is, service bus dependencies, get over it.
Yeah, tough. From a DR perspective, it's a bit of a nightmare. Okay, it's complex. So the service bus has a bunch of databases associated with it. The workflow manager has a bunch of databases associated with it. Your only way to do DR in that scenario is you need to do some form of asynchronous mirroring, asynchronous always on, log shipping, backup and restore of those databases, and then you effectively have to recreate a brand new service bus architecture and a brand new workflow manager farm in whatever your DR location is.
Also using the same encryption key that was used to create the primary farm in the first place as well. So we could probably spend about an hour going through just on doing disaster recovery of Workflow Manager.
And is the Technet article still wrong?
And the Technic article is actually unfortunately wrong. So if you actually want to get some more details, either ping myself or Neil. We can give you the actual steps that will work to doing a warm standby situation for Workflow Manager. Cool, more me. Okay, so hot standby. Okay, so a hot standby is the concept of actually having a hot standby farm. Kind of makes sense. In reality, this is really an HA configuration. So what does that actually mean? Well, let's go through and do a demo on it. So basically, what I've got is I've got a little bit of a demo environment set up here. So what I've got is that I've got a SharePoint farm, which is currently connecting through to my SQL 2 box. And I've also got another SQL 3 box sitting there at the moment as well. So the reason for doing this is that I've got a number of different servers and the naming of them are a little bit wacky. So this is trying to give you the context behind it. So farm5 pointing to SQL 2. What I'm going to do is configure this up live on stage in front of you using SQL Server always on availability groups. Is going to get this configured up such that farm5 will now go into an availability group where I've got SQL 2 and SQL 3 being clustered. And I'll have a SQL listener put in there so that I can actually then have my content DBs go across. Okay? So, here we go. So hopefully this is going to work okay. So what I've gone out, so just to kind of highlight things, down on my left-hand side here, I'm using the Remote Desktop Connection Manager. I've got my farm5 sitting here, and I've gone out, created a simple web application which has got a content DB associated with it, and a straight site collection. Now what I thought I'd do just to prove that this hasn't been rigged up and this is actually going to work, I'm actually going to go through and edit this particular page. And if somebody could just give me some random words to put in here, just to prove that this is actually going to work. Okay, random words. Okay, and thanks for that, John. And I've never met you before, right? It was John. Okay, so random words. And what I thought I'd also do too, just to make this a little bit more interesting, because we're going to get ready for the parties tonight, is I thought I'd just upload a photo that I've got as well. Just kind of found this somewhere. Open that up and put that on there as well.
No prizes for identifying the person, by the way.
Yep. If you saw the name of the photo, it's called SharePimp. So I'll just save this page and then we can actually have a look to see what we've actually got here. Okay, so it's a huge picture. It's come through quite large. So what we've got is...
There's a great session on image renditions in another session, by the way.
So name that person. He's going to be very upset with me later on.
He will when he sees the video.
Okay, so I've got that. So the key thing I've got to do now is to actually get this ready. So I've got my web application that I want to basically put into a high availability mode. So first of all, I need to go into my SQL 2 boxes, and basically what I need to do is actually configure clustering on here. Now to save a bit of time, I've already gone through and installed the feature to enable clustering, but I haven't actually established the cluster on this yet. So what I basically need to do is I go in here, create this little simple wizard, go create cluster, and I'm going to call it always on. Whoops, enter a server name, sorry, that's a bit stupid. SQL 2, add that in, and I'm going to add in the other server that I require here, SQL 3, add, go next, give it a cluster name which is always on, and this is the interesting thing that I need to do in here. So hopefully, can everybody see that okay? Hopefully. I need to give it an IP address as well. So I'm just going to give it a straight 10.10.200, just an arbitrary address that I've actually created here. Now what this basically does is, behind the scenes, it actually, when I create next on this, is actually going to put an entry into DNS, which will create this. So basically, what this means is that when you go to configure this from a clustering perspective, if your DBAs are doing this, they will actually need to have write access back into DNS in order to do this. Now, sometimes your AD admins and your DNS admins don't like this, okay? What you can actually do is go ahead and pre-configure the permissions on that, or actually have that IP address sitting there, so you can actually give them the update permissions on that so they can actually write to it. Just one of those little gotchas that sometimes comes out and bites people. So I'm going to go next, and this should go through and create the wizard for me, create the cluster, I should say.
This is purely Windows clustering, right?
Yeah, this is purely Windows. This has nothing to do with SQL. This is just basically just getting this, joining these two servers together in a cluster. And we're nearly there.
Song and dance?
Song and dance, yep. Okay. Okay, so I've created the cluster. So what we'll see under here when this expands out is I've got my nodes, and I've basically got no services or applications sitting in here which are actually being used as part of the clustered resource that I've got here. Now that's all pretty good, so SQL 2 is now part of that. What I can do is go into my SQL Server Configuration Manager. What I've got to now do is tell SQL that it can actually form part of that cluster. So what I go is go into the service instance, go into the properties, go into this always on availability. It's picked up the fact that it's already in this cluster, and I now need to enable it to pick up and use that availability group. So that's on SQL 2. SQL being SQL, I've got to give it a bit of a kick, so I need to stop it. While it's doing that, I'm going to do the same thing over on SQL 3.
So one of the things to note there is that this isn't, one of the beauties of this is you don't need to install SQL in a clustering mode. This is just a regular SQL install. There's nothing special about this SQL install at all.
And do that, okay, and do that. Now, SQL's a little bit iffy sometimes, so what I tend to do, just to play a little bit safe, I kick it twice, just to make sure. When it's down, put the boot in twice, just to make sure it's actually going to pick up the changes. It's something I do, I play safe, so. The DBAs are probably going, why are you doing that for? That's crazy.
You do the same with your IS servers, right?
I do the same with my IS servers, yep. So just a few seconds while this comes through. Okay, come on. Okay, start that one up. And start it.
I mean, we play with always on, but we're using normal clustering for production. Is this actually supported?
Yes.
Absolutely. Yep.
Absolutely.
Which, sorry?
So I read that some databases.
Yeah, okay. Yeah, so once again, it comes down to the supportability statements on each of the different SharePoint databases that you've got. So once again, you need to look at the matrix associated with that. So basically, a lot of the work's still being defined, okay? So basically, we're still going through a whole lot of testing, et cetera, associated to say which databases are definitely supported. The ones that I'm doing are supported. Okay. Cool, okay. So that's all very good. I've enabled that on the always on for SQL 2 and SQL 3. The other thing I've got to worry about too is actually my firewalls. So the always on uses port 5022. So I've already gone through and created a firewall rule to do this. So basically 5022, I need to enable that rule. Otherwise, if you don't do this, you'll actually go through the configuration wizard when you create the always on availability group. It will appear to kind of work, but never actually finishes. And you're kind of thinking, well, what's actually gone wrong? Why didn't it actually work? It's because your ports aren't actually open. So as a general rule of thumb, get these open up beforehand. If you don't, the easiest way to resolve the issue is actually to delete the availability group and start again and reconfigure it, okay? So I need to done that on that one. I need to do it on the other one, oops, as well. So enable that rule, same type of rule, 5022. Okay. So we've got that. Now I need to basically enable myself to be able to do the always on. So the first thing I've got to do is go through and do a backup of my content DB. Do you like my naming standard on my databases? So this is a bit of a thing that I always do. I like to try and keep my databases on a particular name. So I always prefix them with SP for SharePoint. Then I have my farm number. And then if it's a content DB, I have content. Then the name of the content database that it's actually representing. If it's a service application, then WAC service. So, and then the name of the service application that I've got associated with that.
What's wrong with GUIDs?
I love GUIDs. So just need to do a quick backup. So back that up. And that should just go. Cool. So that's all quite good. So the next thing to do is I've done all the prerequisites. What I've got to do now is go through and create my always on availability group. Now, this is very straightforward to do. All I need to do is run this wizard. So I go next, I give it a name. I'm going to call this SP content. Go next. Now what happens here is that it's actually picking up the databases that I can actually put into my availability group. Now the thing where it's got this prerequisite means that I've actually done a backup of this database beforehand. I have done that of the Content Evolutions database, so we're good to go there. Click on next. I can then add in my different replica. So I'm going to connect through to SQL 3.
So the purpose of taking the backup was to allow the wizard effectively to seed the target solution,
Correct.
The target SQL Server.
And then I can say I want to do synchronous commit. Now, what this basically means, this is actually quite a critical point here. If I don't tick the synchronous commit, it will actually be doing it in asynchronous mode. Okay? So that's why there's no async mode, there's only a sync commit mode. The other thing you notice here too, that we can actually go up to 3. So we can do a synchronous commit to, unlike SQL Server mirroring, where you can only do 2, we can go up to 3. So we could actually have a better high availability associated with this. The other one too that's quite interesting is this readable secondary. So if we have a look at the drop downs that are in here, I've got 3 different options. I've got the option of saying no, I've got the option of saying yes, and I've got read-only intent. And people are kind of thinking, wow, this is pretty cool. I could actually do replication across to another database server or to another farm and be able to access that data as well. Well, sorry guys, this is SharePoint. The only supported option that we're allowed to do is no, okay? Our replicated database is using always on is readable secondary equals no. That's the only thing we can do. So no it is. The next thing I need to worry about, is because I want to basically put in this always on. So basically want to be able the ability to hook in this resource, which is going to be my listener, so I can actually point my connections to that, which will actually enable me to do the failover. So what I'm going to do is I'm going to create a listener. Now this is an optional configuration setting. So if I'm doing this from a high availability perspective, where I'm doing sync commit, I will always create, in fact not always, 99% of the time I'll create a listener. So I'm going to create one of these. I need to give it a name. So I'm going to call it SP listen. Okay, and I'm going to specify a port number. So I'm going to give it port 1433, standard port that SQL always likes to use. Give it a static IP. I could actually go out here and use a DHCP if I wanted to as well. Personally like to try and keep things a little bit more static, if that makes sense. And so I want to be very precise about which one I'm using. So I'm going to go add, make sure I'm using the right subnet. Now this is actually a bit of a trap for some people, particularly in your virtualized environments, if you've got multiple NICs or multiple network cards in your machine. If you get the wrong adapter in here, you can actually get the wrong subnet, okay? And whatever you try to do, it will not work. So just make sure you actually get the correct subnet that's in here. I'm going to give it an IP address, 10.10.201. That should be fairly safe. Go OK. And I should be away laughing. Now, this is the other thing that we need to do too. So basically, as part of this, we need to specify a file share which both SQL 2 and SQL 3, or all of our replicas, can actually see. Basically, what it actually does here is that this is where it puts the log files to. It writes them to, and this is where the other servers actually pick them up and reads them to. So this is a file share that needs to be actually created ahead of time, which I've already done. And I'm then going to go through and run through on this. Everything's come through as being valid. Click on next, and I'm going to now go through and run the summary. Now, what's going to happen as part of this, I'm actually going to get a warning. Basically, the warning is going to say is that I don't actually have a quorum. So what this means is that I've only actually got 2 servers associated within this, which means is that if I get into a disaster or I need to do into a failover situation, I really need a third node out there to actually form part of the quorum to say, right, who's actually the primary here? Now, although I can do this, this appears to work great, okay, and I can actually get this up and going. What could potentially happen is that if I do a failover, okay, and this then bring down my other server and bring it back up again, and I've done a manual failover, it doesn't actually know when this other server comes up that it's no longer the primary, because there's no third node to go out and connect to. Okay, so basically the important point here is that if you're going to do this, make sure you do actually have a quorum involved in this, have a third server, or you can actually use a file system quorum, a node, I should say, in there, which actually works quite well as well.
Just before you click on Wayne,
Yep.
if you don't open the firewall port that Wayne was referring to earlier, this last step here will just sit spinning. If
Yep.
you get into that scenario and it's just spinning,
Yep.
it's almost 99% of the time it's going to be because the firewall port's not open.
Yeah, so port 5022 needs to be opened up. Okay, so that's closed. Okay, so what we can look at now is we can see what our available replicas are. We can see that from SQL Server we've got SQL 2, SQL 3. We've got our available databases, so we've got our content DB put in there. We've also got our listener, so our listener in here is called SP Listen. Now what is interesting, if I go back to my cluster, and there's my SP content, and this is the actual resource that's actually been put in there as well, with my SP Listen in there. So this is the thing that's actually been clustered, that particular resource. So if my SQL 2 box goes down, it will automatically fail over to SQL 3 as well. So we're all good to go, okay, from that. So in theory, if I go back to my, if I've got my farm over here, this should all still be working. Refresh the page. I've still got my share pimp down on the page down in there, okay, that's still there. However, there is a gotcha on this. What I've done is that when I created this particular web application and pointed to the content database, I actually just used the default settings. So what's actually happened here is that I've picked up basically what my default connection string is, which was to point to SQL 2. What I've got to do is basically do something a little bit nasty. I've got to dismount that content database from there.
Which you would, of course, do in a plan change window.
Do through my plain change window, okay? This is something you don't really want to do in production. So that's going to dismount that. I then need to go in, create my new SQL alias. So I'm going to add a new alias in here. So basically it was SP Listen. Oops. Okay, and I want to call that alias. Get rid of that. Go there. Go back to port 1433. Okay. So what I'm doing here is that I'm creating a new SQL Server alias, which is pointing to that listener. Okay, makes sense? So our connection string now is going to that listener. I then can reconnect my content DB. Oops, I called it content before, just change the name on that.
Did you apply that?
Okay, and if I run that particular bit of PowerShell, that's going to remount the content database using that new connection string, which is now pointing to the listener. What this basically means now is that when I fail over, it's going to basically follow and use the listener, and the listener will go over to the other one, and I'll still be able to render content. hopefully. Database server, come on, why are you taking so long?
It's that big picture.
It's that
Put
big
in that
picture.
database.
It probably is the big picture. It was a huge picture. Okay.
No, did you apply the alias?
Cannot.
You didn't apply the alias, did you?
I didn't apply the alias. I did not apply the alias. Thank you. Okay. So that worked that time. Now, the one other thing I need to worry about as well, which is somebody kind of called out the permissions. Because I'm actually pointing across to a different server, okay, I need to actually worry about the service accounts that I've actually got running under here. So what that basically means is I need to be able to provide, because this is a web application, my web application service account access to that particular database. Now the good thing about this is that if I go and look at my databases here, we see that it's already been synchronized. I can't do much in there, but if I go into my logins, go new login, add in my service account, SP5 web app. Okay, all I need to do is actually add that account in because it's already not found. Okay, F5. Go across on that. Now, if I look into this, basically it's already done the user mapping through into my one that I've got there. Well, it's not seeing it because it hasn't failed over. If I quickly go over and fail this over, dun, dun, dun. Let's go back here. Dun, dun. Oops. Do a manual failover. Go next. Next. Connect through. SQL 3. Next. Finish. Okay. Now that's just going to take a few seconds to go through. So if we
5 minutes.
Yep, okay. I want to get another demo done as well. Okay, so I'll come back and show you that in a few seconds. So the other thing that we're going to look at quickly is looking at what was called the warm standbys. Now the key thing about these is that they're actually, unfortunately, quite complex to do. The issue here is that it really depends on the service applications and the associated databases that you've got. So basically what you need to do is look at what are the service applications you've got, what are the SLAs that you've got associated with those, okay, and what can you actually replicate and take through. It also basically means that you do need to have two sets of failover processes. You need to have a planned failover process and an unplanned process in order to do this. These are complex, they're hard, they need to be tested, and we could probably spend about a day just talking about this particular. So for this particular demo, basically my start environment is farm 5 pointing to SQL 2. I've got another farm 6 pointing to SQL 3. I've already configured the failover cluster, which you saw me do. What I'm going to do towards the end of the environment is basically take out farm 5. So to make this nice and simple, to speed up a little bit of time, I'm only going to do one service application as an example for this. So switching back. Results from that one was action required. So basically it's given me the warning because of the quorum not there. Okay, if I go back to over here, back to my farm, if I render that page, that should still actually render. We should be away laughing. So trust me, that's failed over. We're actually up and going. We're all good on that. So the next one is what we're going to do is take through the secure store service application. Now basically there's a number of different steps you can do on this, or different approaches you can do on it. Now, you can either do a database backup and take that across, or you can do the way that I actually prefer to do it, which is to go through, do a backup of that particular service application, okay, and grab that. Now, the reason for doing that is that if you think about service applications, some of the configuration settings are actually stored in the config DB. So they're not actually stored in the actual service application database. So you could have things like permissions, etc., associated with this, or you could have some of the properties, so particularly like the managed metadata has some properties on the proxy. If you don't actually pick those up or know what those are, you could potentially miss them. So as a general rule of thumb for myself, I play safe. I do a backup, a SharePoint backup of it, which is pretty straightforward to do. We go through into here. go into our service applications, choose our secure store, and basically run that wizard through. Now, I've already done this already, so I've already done a backup of the secure store service application as well as the proxy, and I've already gone through onto my other farm, and I've already gone through and done a backup. I've already done a restore from the backup of those two service applications. Now, just to show you one thing, though, you need to be wary of. As part of this process, when you do the restore of the service application, you need to pay particular attention to what is the logon account that you're actually going to be using. So this needs, in this particular case, needs to be the service application pool service account. Now, this is different for this farm, so that needs to be 6. I need to enter in the password, okay? And the other thing I need to change here from the backup is what is the name of the SQL server that I'm actually going to be pointing it to. So it needs to be, in this case, SQL Server 3. If I hit that and run that, it's basically going to restore that database, restore that service application in my other farm, and I'm good to go. Now, this does take a little bit of time to do, so I'm not going to do it. Once I've done that, if I go to SQL 3, I've already got my secure store service application, so that's already sitting over there. However, I want to create an availability group using that database, but it's already there, so I can't actually do anything with it. So what I'm going to do is something which freaks a lot of people out.
Including me.
I'm going to right-click on it and go delete, close existing connections, and wave goodbye to it. So what I've actually done is something that was a little bit wacky. Okay, I've actually taken a backup, I've restored the database over onto my other farm, then deleted the database out. The reason behind that is that SharePoint still knows about this particular database and all the settings with it. It's just gone from SQL. I can then go to back to my availability groups, go in here, go a new availability group, go next, give this another name, so I'm going to call this SP Service, go next. Basically, I've already done the backup of this particular database, so if I go into SP5 Secure Service, where's it gone? Secure Store, all right in front of me. Go next, add the replica, connect through. This time I don't check any of the boxes because I'm going to do asynchronous commit. I'm not going to create a listener, okay? I could create a listener if I wanted to, it wouldn't hurt. Okay. However, typically when I'm doing asynchronous, I won't. The reason behind that is that if it's located in a different data center, I could potentially get into a stretched farm location situation if I do a failover and I'm pointing to the listener. Make sense? Okay. So you just need to think about what's actually happening here and where things are sitting. Do a quick next. Backups again. Do the validation. We now get a warning saying we're not using the listener. I go, so what? I know what I'm doing, trust me, believe it or not. Okay, I've now got that going, got the same quorum issue going, got that across in here. SQL 3, the other thing I need to basically do is worry about the permissions. So I need to go into security logins, go new login. Sorry, no I don't. I need to go to my service app. Okay, give this one permissions to the secure store. Oh, it hasn't come across yet, so I can't touch that. Oh, sorry. I can't touch it yet. I have to wait to do a failover. Go back here, do a failover. Go next, go next. It's given me a warning now. Because I'm doing asynchronous commit, there can potentially be some data loss associated with this. I'm going to take the plunge, go next, know what I'm doing, go connect, next, finish. And basically now I'm failing over to the other SQL box and to my other farm. And we are good to go on that. Basically, if I go into that other farm, go into the service application, application management, manage service applications, secure store. It will tell me I need to generate the key because it's the first time I've gone in here to the farm. The other thing that's quite interesting too is that if I look at the availability group just refresh that. Basically, I need to reinitiate the data flow back, and we're running out of time.
Yeah, we're short on time.
Yep. But anyway, if people want to see this a bit more, I can show you after.
It does work.
It does work. Okay. So anyway, the other option is going to cold standbys. Basically, this is a SharePoint backup and restore. You can use native tools, third-party tools. Now, basically, I'm going to pimp to go and see the twins, Chris and Sam. Okay. Basically, they're going to go through and show you how to do backup and recovery with DPM 2012. Now, that's Tuesday, today at 4:15 in this room. Highly recommend to come and see that session. It should be a bit of fun and a lot of good things to do. So, in summary, key thing about this is know the difference between HR and disaster recovery. Basically, when you start talking about these, make sure you talk about RPO, RTO, SLAs, and fault domains. Make sure you get these defined out front. Look at hot standbys, kind of seeing how those work. Look at warm standbys, seeing how they work, and thank you for attending.